Hey everybody, welcome back to another episode. Today we're going to be looking at graphing linear functions. I'm really excited for today and I hope you guys are as well. Hopefully the last video was a good introduction. Today we're going to go even further into graphing. Let's get started. Some things we need to remember. The equation for every straight line we're going to use is y equals k times x plus m. Let's focus in on the letter k. The letter k is going to represent the slope. The k value can tell us two different things. It's going to tell us the steepness and the direction of our line graph. The letter m in our equation is telling us where the line crosses the y-axis. Another name for this can be called the y-intercept. And our goal today, by the end of the video, we should be able to graph the line by just looking at our equation. Or by looking at the graph, we can determine the equation. Let's get started. So what is the slope? Some of you might be asking yourselves. Oftentimes when we think of slope, some of these images come to mind. Whether you're biking uphill or downhill or on a flat surface, slope refers to the steepness. When we think of a hill, we think of how steep is that hill, or what is the slope of that hill. Some are going up, some are going down, some are going flat. So in graphing, slope is going to refer to two things. It's the direction and it's the steepness, whether our line on our graph is flat or not. And slope is going to be letter K, our equation. Keep this in mind as we move along. So let's take a look at some examples. We have equations and we have graphs. Just remember that these are not the equations for the graphs below. The slope of the line can be measured in two different ways. In one way, we can look at the equation and we can read the equation and look for letter K. And letter K is always attached or is beside letter X because, well, the slope is a coefficient in front of X. So by looking at the equations, we can determine what the slope will be. In another way, we might not see the equation, but we have a graph. By looking at the graph, we are able to calculate what the slope can be. So let's look at one way we can calculate slope. Calculating slope from the graph. The equation we're going to use to find the slope is we need to find the vertical change, the horizontal change. And the change we're finding is between two coordinates. So in the picture below, we have two coordinates. We're going to find the vertical change between them and the horizontal change. Another way we can talk about is we're finding the change in the y values. The vertical change is dealing with the values on our y-axis. The horizontal change, well, that's dealing with the change in our x values, or the change in our horizontal axis. An extra one we can do is y2 minus y1 minus x2 minus x1. Basically what this refers to is if we have 2 points, we call this perhaps x2, y2, because they're x and y. We can call this maybe x1, y1. Two coordinates, the subscripts just show that we have coordinates number 1, coordinates number 2. The equation I would like you to remember today is the slope is going to be equal to the rise divided by our run. What I mean by rise is our movement up or down, and our run is the movement to the right. So, our slope, let's calculate this together. We need to go from this coordinate down to this coordinate. So our vertical change, we're finding the difference between our y values. So if we follow this formula here, we have y2, which is 3, minus y1, -1. Another way to look at it is we're trying to find the vertical change. How much does it go down? So this is our rise. In this case, we're rising down, or we're our movement down. And our run. Well, we need to know how much we move horizontally or move to the right. We can do this by doing -3 minus 3, or x2 minus x1. 3 is our x2 value. Our x1 value is 3. Finding the difference, so we're subtracting. And another way of looking at it is we're trying to find the difference in our horizontal movements. We can call this the run. Here's our rise. Here's our run. Let's calculate this. 3 subtract -1 is the same as 3 plus 1. And -3 subtract -3 subtract 3, well, we get -6. 3 plus 1 is 4 over -6. Let's check in our graph to see if we match up. 4, are we rising 4? Well, we're moving 4, so we go 1, 2, 3, 4. Our movement down is 4, and this means that our run should be 6, so let's check. 1, 2, 3, 4, 5. Another way to write this, we can write the -4 over 6. And if we simplify this, this is the same as -3. When we're writing our slope, the negative symbol is going to be associated with our rise. Because remember, we said our rise is our movement up or down. And our movement to the right, well, we're only going one direction. The negative sign is going to tell us whether we're going up or down. And in this case, negative is going to represent down. So our slope, right, is -2 over 3. Great. So this is our k value in our equation. Calculating the slope from an equation. Remember, our equation is the slope is equal to the rise divided by the run. Our change in our up or down movements divided by our change in our movement horizontally. Here you have an example. Y is equal to -1 over 2. X plus 2. Second example, we have y equals 2x plus 1. And our third example, y is equal to 3x minus 1. At this point, pause the video. Try to determine the slope for each equation. We're going to do this now. Remember, our k value is the value that is beside our x value. It's our coefficient. So in this case, our slope is going to be -1 over 2. Remember, the negative is associated with the rise. So this is also -1 over 2. That means we're going to go down 1, right 2. The next example, our slope, this value here, 2. However, remember, our slope requires two movements, a rise and a run. We have our rise. To make this a fraction, we can write it as 2 over 1. That means that we're going to go up 2 to the right And the last example, our slope. Nicely written, it's 3 over 2. Means we're going to go up 3, right. So determining the slope from our equation is a bit easier than determining from the graph. But we've shown two different ways to find the slope. Let's continue on. The y-intercept is, as you see in the picture, it's where the line crosses the y-axis. Remember, our y-axis is our vertical axis. Other way, write it. So the line crosses the y-axis at a certain coordinate. And this x value is always 0 because, well, there's the value of x is 0. It always lines up with the y-axis. So x is always 0. And our y value, this is going to be given in our equation. Finding the y-intercept. We have two scenarios we're going to do from the graph. When we look at the graph, quickly see that the line crosses y-axis at this coordinate here. Remember, we said our x-coordinate is always 0. Our y-coordinate in this case is 1. So this is our y-intercept. It intercepts the y. And from our equation, remember the m value is our y-intercept. Remember, k is our slope. So we see that the y-intercept for this scenario, 2. But it's not just 2. Remember, x is 0. The 2 gives us our y value. Take a look at another example. Here's the m value. That means our coordinates are 0, 1. X is 0 and y is given. Try one more example. Here we have -1. So we have x is 0, y is negative. There's two different ways to finding the y-intercept. So the goal today was to be able to graph our equation or function by just looking at the equation. And I think at this point we've developed enough tools to do this. So let's look at our equation here. We have y is equal to 2x minus 1. Underneath we have y equals kx plus n. Remember, we said that k is the slope, where slope is equal to rise over run, and m is our y-intercept. We have 0, and our m value is our y. Remember, rise, if it's positive, we're going up. If it's negative, we're going down. And our run, well, we're moving to the right. Good way to start is by looking at the y-intercept. Look at this m value. The y-intercept, where it's always 0, and our m value, and in this case, it's going to be 0, -1. Let's locate that on the y-axis. X is 0, y is -1. Here's our y-intercept. -1. And from here we need to know what the slope is. When we look at 2x, our slope is the k value, which is 2. However, we need to write this as a fraction. 2 over 1, where 2 is our rise, 1 is our run. That means from this point, we're going to go up 2 right 1. So let's go up to run 1, up to. You notice it kind of looks like a staircase going up because there's 2 movements. We need to rise 2, need to run 1. And you can continue this until you feel it's enough. And remember, at the end, we need to get our rulers and draw a line. Do your best. Remember, the arrows at the ends show that the line continues forever. There you have it. That is how you graph without using a table. Good job. Sometimes you might be asked, is the graph proportional? What it really means is, does the graph go through the origin? And well, in this case, it does not enter. This is the origin. It does not cross the origin. Therefore, we can say, no, this is not a proportional graph. So in general, we need to recap what we talked about. Proportionality or proportional, we just talked about when the graph crosses the origin, 0, 0. Yes or no question. Some pictures here to represent different types of slopes that we might have. Take a look at that. We'll discuss this in the next video. Thanks for tuning in today. I hope this video was helpful. If you enjoyed the video, don't forget to subscribe to my channel. And if this video was helpful, well, please like it as well. Thank you very much. Have a nice day.